A block of mass 250 gram is kept on a vertical spring of a spring constant 100 Newton per meter. A block of mass 200 gram is kept on a vertical spring. So we have a vertical spring, suppose like this, and a mass of 200 gram is kept on it. 250 gram is kept on it. Okay. A spring constant K is given 100 Newton per meter, fixed from below. The spring is now compressed to have length 10 centimeters shorter than its natural length. And the system is released from this position. So from the natural length, it is compressed by 10 centimeter. Okay. And then released from this position. How high does the block rise? Okay. So the block is kept. See, it is not attached with the spring. So this word we have to see clearly, because when the block is attached and when the block is kept, there are slight difference in that. When the block is kept on it, if the block is kept on it, while moving upward, the block can separate from the spring. Okay. But if it is attached with the spring, the block will not separate from the spring. Okay. So if it is just kept, it may separate from the spring. But if it is attached, it will not separate. Okay. So if it is not separate, if it will not separate, then if it will not separate, it means what? If it will not separate means it may stretch the spring further. The spring may get stretched further. But in this case, we can see that block is kept. So the spring will not get stretched. The block will get separated. So after compressing, suppose it was compressed by 10 centimeter, and when it is relaxing, suppose it is going upward, and when it is relaxing, the block may separate. Okay. So we are writing the energy for this situation. So we are having only two forces, gravitation and a spring force, no external force. So work done by external force is 0. So change of kinetic energy plus change of potential energy will be equal to 0. So what we can write is change of kinetic energy. So initially it is compressed, okay, and released, and at highest point again it will come to rest. So initially the U was 0 at compression, and finally when it is rising to highest point, at this point again the velocity will become 0. So we have to find what? How high the block will rise. So at highest point again velocity is 0. So velocity is 0 at the lowest point and also at highest point. So the kinetic energy change is 0. So that is 0 minus 0. And potential energy will have two parts, that is spring potential energy plus gravitational potential energy equal to 0. So what will be spring potential energy? So how much is spring is compressed? So the spring is now compressed to have 10 centimeters shorter than natural length. Okay. So it is compression is 10 centimeter. The compression is 10 centimeter. The X is 10 centimeter because it is clearly writing the spring is now compressed to have length 10 centimeters shorter. So half K X square, that is initial, and finally it will be 0 because spring is finally relaxed. After the block separates, the spring will get relaxed. So final is 0, initial is half K X square. And what about gravitational potential energy? So if it rises to height h, we can write mgh equal to 0. Okay. So h will be equal to half kx square into divided by mg. Okay. So half, how much is k? K is 100. And mg, how much is mg? Mg is 250 grams. So 0.25 into 10, 0.25 into 10 m into g, and 2, and k is 100, and x was how much? 10 centimeters. So that is 0.1 meter. So we can write 0.1 square. Okay, so this we have to solve. So these two will get cancelled. So we are having height is equal to 2.5 into 2.5 into 2. So 1 by 5 we are getting. So 0.2 meter or 20 centimeter. We are getting a height of 20 centimeter. Okay. So the object rises by height 20 centimeter above the initial compressed position.